Welcome to Emtron Training Part 44. In this training tutorial, we're going to be taking a look at working with our closed loop style boost control. Our closed loop boost allows us to have a boost target and allow the Emtron to look at the target, figure out the difference between our manifold pressure, it'll calculate what's known as a boost error, and make adjustments to the duty cycle we're sending to the boost control solenoid. In the last video, we worked with the open loop style control. This is going to be building upon what we've talked about and learned already in the last video and introducing a few more things that we need to account for in programming and working with our closed loop control. We're going to have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with closed loop boost control tuning in our Emtron ECU. Our closed loop boost control allows us to specify a target boost that we want to run. The Emtron will take a look at what the map pressure sensor is reading, compare the difference between the target boost and the actual map pressure. It's going to calculate an error. Based on that error, it can start to influence what the duty cycle we're sending to the boost control solenoid is going to do. It can either increase or decrease that duty cycle to be able to increase or decrease the boost to reach that desired target. Now, boost control in closed loop format hinges upon having a few basic principles accounted for and dialed in before we actually enable the closed loop option. In fact, in the last tutorial, we've covered working with our open loop style boost control, which is the basis for jumping into closed loop boost control. You may have skipped over that last video, so I want to make sure that I'm covering everything complete from start to finish in this closed loop style video. Now, what I'm going to do here is jump into the beginning of the video. We're going to talk about the relationship between a turbocharger, a wastegate, and the boost control solenoid, go over the routing for a boost control solenoid for a 3-port solenoid specifically. That's what I work with and have had the best luck with. I don't prefer to work with 4-port solenoids. And we're going to go in and take a look at the setup configuration details, taking a look at the actual programming that we need to do in the boost control tables and how everything fits together. And then finally, how the closed loop PID gains function and how we can program and tune them. Again, it's relatively straightforward as long as we're following along with what I'm covering and outlining in the tutorial. So the first thing we're going to begin here is talking about the relationship, the basics, a turbocharger, a wastegate, a boost solenoid. Let's dig into this so we understand before we move into the setup and configuration and programming details. Now, what we're going to have, we have an engine. It's going to be fitted with an exhaust manifold. On a turbocharged engine, that exhaust manifold is going to deposit into a turbine housing. So the exhaust flow and exhaust gas and pressure is going to go into the turbine housing. Within that housing is a turbine wheel. The turbine wheel will spin faster and faster depending on how much pressure and flow move through the turbine housing. Now, that turbine wheel is linked on a common shaft to a compressor wheel. The compressor wheel is inside a compressor housing. As the compressor wheel linked with the turbine wheel spins faster and faster, it'll start to pull in more air on the compressor inlet. It'll compress it inside that compressor housing and discharge it out of the compressor outlet. What we'll find is the faster that we spin the compressor, the more airflow it's pulling in, and it's going to have a multiplying effect and essentially giving more flow output that's going to be displaced into the engine. Now, the compressor outlet is going to go through a charge pipe to an intercooler, from the intercooler into the throttle body into the engine. So as our compressor spins faster, we'll generate more boost pressure and generate more airflow into the engine. The airflow is what makes the power, and that's what we need to make sure we're regulating within the boost control. We don't want that compressor to spin too fast, because if we do, we might generate too much boost pressure, too much flow, and damage the engine. That's specifically related to how the engine mechanical internals, how strong they're going to be. Also, what kind of octane fuel we're dealing with. We might not have enough octane to support higher flow and higher boost levels past a certain point, or the mechanical strength of the engine internals can't support anything past a certain point. So we want to make sure we're very specific with this. How much airflow we're allowing into the engine, how much boost pressure we're allowing into the engine. Now, what we're going to find is that in order to regulate that compressor speed or how fast we're spinning that compressor wheel, we need to regulate how fast we're spinning our turbine wheel. And that's where a wastegate comes into play. What we'll find, again, if we leave it unregulated, all of the exhaust gas, all of the exhaust pressure will go into the turbine housing, spinning that turbine wheel faster and faster. And in fact, it's going to have a certain point where it will start to reach a peak RPM that may spin the compressor up to something like 30, 40, or 50 pounds of boost. Way over boosting, definitely going to damage our engine. We need to slow that turbine wheel down and then therefore slowing down the compressor wheel at a regulated amount. A wastegate
is fitted either on the exhaust manifold with an external wastegate or on the turbine housing with an internal wastegate to be able to regulate how much exhaust flow and pressure come through the turbine housing. Now let's take a look here at an internal wastegate first, then we'll talk about an external wastegate. The internal wastegate is packaged on most OEM turbos. It's going to be for nice packaging constraint reasons. Everything fits neat and nice. It's going to be the most simplistic way to control boost compared to an external wastegate. External wastegate you'll find typically on aftermarket turbocharged setups, but an internal wastegate will be found primarily on OEM applications and on aftermarket applications. But we'll find that the internal wastegate is what we'll start off with here. That's, again, the most simplistic way in terms of the actual wastegate control. Now, taking a look at the internal wastegate, we're going to find that we have a flapper door that's fitted onto the turbine housing. If that flapper door is closed, all the way shut, no exhaust gas is bypassing from the hole that the flapper door.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.